Hello people! Again, it's been quite a while since my last video. Again, I've been very busy doing many things. I'm working 4 days a week at one job and 1 day at another job. And evenings I'm working at some of my projects and also trying to find some time to relax and be with my girl, so not much time. Well, lots of time, but also lots of work, but that's how I like it. But now I'm in the mood of making a video, so you're actually gonna get one. So the last time I was using this cutter, I ran into an electrical problem with the milling machine itself. But now it's sorted out and I'm ready to do some more milling. So this is Coromill 300, which uses 4 round 12mm inserts. And this time I want to find the max cut for this milling machine. So we were going a little bit slow last time. After that video I found out that these inserts are actually okay with 200 millimeters per minute of cutting speed for ISO P grade materials, so in other words for steel. But first we're gonna try it with aluminum. This is a 6083 aluminum, I think, 6083 or 82. And we're gonna try some pretty serious cutting speeds. So last time we were going at I think it was 800 RPM and 630 millimeters per minute feed. And now we're gonna double it. So we are using the maximum spindle speed and the maximum feeds on this lathe, on this milling machine, sorry. And as you can hear from my speech again, I'm making a lot of mistakes and misspeaking and everything and misthinking. So I will be adding some annotations to the video. So if you're using a mobile device to watch the video, maybe you cannot see the annotations, but the real good stuff is on the or in the annotations. It's not what I'm speaking at the moment, because I have to pay so much attention to my English speaking, so that my thought is not running as well as it normally would. Yeah, sure. Okay, so I think we are ready to start cutting. Actually, these inserts are not meant for aluminum, but I think they will do just fine. I will use some coolant. Actually, it will be a brake cleaner, which is some kind of an alcohol-based fluid. It's not the best, but that's what I got at the moment. I think it's gonna work just fine. Mainly just to stop the chips from welding to the inserts. And the cutting speed is now 260 meters per minute, and the spindle speed is 1600, which is the maximum RPM on this milling machine. And the feed rate will be 1600 millimeters per minute, which is also the maximum feed on this machine. And it's actually the fastest feeding speed that I have ever run on any machine. It's even faster than on the CNC milling machine at my school. I think I was running the end mill. Actually, let me show you that end mill. I happen to have it here. So I was running this end mill at I think 3.5 or 3000 RPM. And a feed rate of 1200 millimeters per minute, and it was working great. But now, since this is kind of a high feed cutter, I'm trying to run it much faster. And actually the feed per tooth is exactly the same as in my previous video. So it's actually not loading the tool anymore. I mean, talking about chip load. Of course, the higher speed will add some more heat to the tool. But the main restraint here will be the milling machine itself. I think we are gonna run out of motor power. So, enough talking. Let's make some chips. Okay, the mill is gonna make some noise at the highest speed, but let's see. Actually, it's not that loud at all. I think the rapid feeds on this mill are only 2000 millimeters or 2 meters per minute, and the feed rate now is 1.6 meters, so it's almost the same using the feed or the rapid traverse. So I think we are ready to start milling, and again we are trying to climb mill, so taking more on the ingoing side than the outcoming side. So going from thick to thin, which you should always try to do. So let's touch off. Can you see? I'm sorry, the lighting is not as good as previously. I hope you can still see pretty well. Okay. Let me get the coolant. I think this might actually be pretty good coolant for aluminum. It's a large bottle of brake cleaner. So, first let me demonstrate you just how fast the feed is. Let's first feed in 1 millimeter. It should be pretty easy. Let's see how it goes. Okay, that was pretty nice. No issues at all. It's going fine. Surface finish is a little bit rough, as it was last time. Pretty much no chip welding, which is great. Let's fit back and go the other way. Okay, now let's take some real cuts. So, actually it's going a little bit easier than I thought. So this was 1 millimeter. let's go for 2 millimeters. Actually, let's take 1.5 first. This should still be quite easy, but this is now removing metal twice as fast as the last cuts on my last video. But the material is aluminum and it's much easier to cut. Okay, no problem. Let's go for 2. Still not a problem at all. So let's go 2.5. I think what's gonna happen is that I should have a faster feed or a faster spindle speed. It might be that the inserts, this type of a tool cannot take a cut tough enough for the motor to stall. So I should have way more spindle speed and then up the feed again. But at the settings that I can use on this milling machine, actually the settings are the limiting factor. I don't think I can go much more than this. So maybe after this cut, if it goes well, we can try again with steel. But this should also be a pretty tough cut. Let's see. Okay. What's happening now is the depth of cut is increasing so much and that the chip thickness will be too thick. I think I could go a little bit deeper, but I think it's a little bit risky. So actually let's stop here. And I will now turn the piece around and face the other side. So this piece should be equal in thickness. And actually, if you are fanatic enough, me fanatic, that you will actually listen to my every word, which I doubt many of you do, I will now reveal that this piece is actually a test piece for something else, which might be coming. And it probably is coming. And I'm really excited about that. And I'm gonna try it out tomorrow for the second time. and hopefully in about 2 weeks we will see more about that, but I will not say more about it at the moment, so you can make your guesses. Okay, no more about that for now. Let's flip the piece. Okay, the piece of steel is now set up pretty tightly on the vise, and I think we are gonna use the same cutting parameters, just starting with a shallower depth of cut, and I think we're all set for trying it out. So let's first start with just 0.5 millimeter, which is right here. So let's go, and this will be a whole different game than aluminum. Whoops! What's wrong with my settings? I should have zeroed it. Let's retry. Okay, I was 1 millimeter off somehow. Let's go again. Okay. Okay, still going fine. The piece just didn't clean very well. Let's go again right here. Okay, it was certainly taking a little bit deeper cut on this side, and as you can see, it's actually cutting more, and that was also putting some serious strain on the motor, which is great actually. Let's clean up the middle part, and then I think we might try a full millimeter of cut. Okay, let's go here. Everything looks good so far. Just messing with my coordinate settings. Okay, this looks pretty good for the width of cut. Now let's go for 3/4 of a millimeter first. Okay, that's just too easy, and the surface finish is still great and shiny. Let me try to move the camera a little bit so that you might actually get a little bit better view. This might be a little bit better. Okay. Again, let's clean the piece, and next up will be a full millimeter of cut. I think I will just move the camera to the mag base. Just a minute. Okay, this is a much better view for you. So, as you probably figured out by yourself until now, everything else is now maxed. The only thing that can change is the depth of cut. The mill is now maxed. Max settings on spindle speed and feeds. Okay, let's feed down a full millimeter. Let's see if my dials are correct this time. They seem to be pretty good. Yeah, it's pretty good. So, feeding down a full millimeter. And using full width of cut of the mill. Okay, let's go. Okay, the cut went just fine, but again I proved myself for being an idiot, because I placed one of the tripod's foot somewhere else but on the table of the machine, so it tried to walk away. Let's try again. Okay, better maybe. So, 1 millimeter, no problem. Let's clean up the piece. Let's clean up the piece. Sorry for my mess. Okay, not much better placing for the camera. Okay, let me get the mag base. Just a minute. Okay, this should be about as good as I can get. Take a look at this surface finish. It's pretty darn good. It's got some stripes on it, but and that's what I got on the previous video as well. So it's most probably one of the inserts not sitting perfectly on its seat, but that's just fine. Okay, let's clean up the middle and then take some more. Okay, so I just took points. Actually, this was a full millimeter. So let's go slow. Let's go 1¼ millimeter. Okay, let's see. Okay, no problems. 1¼ inch, and as you can see, it really was a full width of cut because it left a little bit of an edge here. So I must go a little bit less wide next time. Actually, I think I want to remove that tiny little edge. Don't know about you, but I certainly like what I see. And now let's go for 1½. And now this is exactly twice the metal removal rate we had on the last video. So in other words, the cutting speed is now maxing out the inserts pretty much. So it's at the highest recommended cutting speed, which is like 250 meters per minute. And the DOC depth of cut is closing the recommended maximum value also. So I think this tool is actually pretty well sized for this machine. But the motor also sounds like it won't take too much before it stalls. Okay, let's take 1½, which is now dialed in. Let's go. pretty nice. It actually went really well. I think we can still try more. I think we can still go 1.75. This is a large cut, especially for a manual machine. I have never seen anybody on YouTube machining metal this fast on a manual milling machine. If you have manual machines yourself, try this out. Just be careful. So it would be nice to compare results. Okay, I'm just amazed how much this machine actually can take. I thought it would stall out at about 1 millimeter. Which we passed long ago. Actually, we're going for 2 millimeters now. So, let's go for 2 millimeters. And you may remember on the last video 2 millimeters was the max cut that I took at the end of the video. The very last pass on that video before the machine broke down was 2 millimeters. I will reposition the camera so maybe you can see how the chips actually fly. I think one might describe it as a mighty spray of chips. Okay, let's go for 2 millimeters, and I think this is pretty much the maximum that this machine can take. But one thing for sure, it is the maximum that I can take. I will not take a deeper cut than this. This is where I will stop. So this is the very final depth of cut that I'm gonna try. Okay, let's go. Just awesome. I think it could still take more. I had no idea it would go this far. And still take a look at the surface finish, it's beautiful. Beautiful, shiny, and absolutely no vibration. And that's amazing. So, I think this is where I'm gonna stop. Let's see if I can show you a chip. Beautiful golden color. I don't know which thickness this chip was made from. I wish I had taken samples from each pass. So, I think this pretty much concludes the testing of this machine and testing of the tool of the Sandvik Coromill R300. So amazing tool and amazing machine. Such an old, worn-out piece of junk, but it's taking huge cuts for a manual machine anyways. So, not much theory talking in this video, but I think you can find pretty good theory explanations on the previous video. Just read the annotations, do not listen to my stupid speech. And I think I will add some annotations to this video as well. Okay, so I'm pretty speechless at the moment.